Hello everyone. So in this media we are going to discuss about MEGI and MEGA. So before we move further, this was a direct question by the surveyor that what is the difference between MEGI and MEGA. So we'll stick to the topic and we'll discuss here the difference directly between MEGI and MEGA. But before we move further, we have to know that this ME nomenclature, this M here M, this M stands for the type of engine. That E is that we have electronically controlled. Okay, because M you must have sailed on ME engines. That it may be type B, type C also, and then we have GI, which is known as that is gas injection and gas admission. So that is the difference between GI and GA. So this one stands for gas injection and gas admission. So what is the difference between them, we'll see in our further course of action. So we have two options for engine. See, when we speak about LNG ships, so they were basically started building after 1964, you can say roughly, but they were of steam turbine. So here we are not bothered, or here we are not going to discuss about those steam turbine. But why those steam turbine became obsolete, the reason being was that of cost disadvantages. So we had cost disadvantages with this steam turbine which were steam propelled. Now when we see further, then in 2002, after 2002 somewhat, we started with again dual fuel engine and tri-fuel engine as well. Okay, now in from 2012, so we had slow speed two stroke. We have ships which were propelled by gas. So the ships which were propelled by gas. Earlier we had ships which were carrying LNGs, but they were steam turbine driven. Okay, now you know why is LNG this comes in picture and why it became advantageous. Maybe I will cover a separate video in MEGI, because now we only have MEGI. MEGA is obsolete now, maybe somewhere in 2024, before 2024. So now what we have only is MEGI. So I'll make a separate video on MEGI wherein we'll discuss all the aspects of MEGI. Okay, how it is there and what is the method and how injection is happening, what is pilot, how much consumption, why it is advantageous, everything we are going to discuss. So we know that in LNG ships we are carrying their special design tanks. I've also covered the types of tank on gas carriers. You can watch that video. And we'll be so there is a boil off, and from that boil off this LNG is being used in the main engine. So that was the major chunk of advantage over steam turbine, which were ships which were driven by steam turbine. Maybe 0.1% to 0.5%, this much of boil off that is being wasted. So in a month you can say for ship with 30,000 liters of LNG that could have go waste. Okay, now first we'll see what all gas engines we have. So MELGIM, okay, gas injection, that is methanol. Okay, when we have methanol, this was a separate question altogether. I have made in a shorts also. MELGIM is for nomenclature given by MAN, diesel and turbo. Now no more MAN, B&W. Okay, MELGIE, that is for ethanol. MEGI and MEGA, that is for LNG as a fuel. When we use methanol as a fuel, then we have MELGIM. When we use ethanol as a fuel, then we use nomenclature as MELGIE. And now when we use LNG as a fuel, then we have MEGI and MEGA. So that is gas injection and gas admission. Now we also have ammonia as a fuel, but now no more nomenclature has been assigned yet, so we are not going to discuss. But we also use, so these grades of fuels we have, obviously we have hydrogen fuel also, hydrogen propelled. We are not going to discuss in them because they are in trial stages. Okay, Costco shipping, they develop when hydrogen propelled engine. Okay, so it is a cleanest fuel. Now, dual fuel engine means what? VLSFO, MGO, MDO mode, and with EGR, they are tier 3 compliant. So keep in mind that dual fuel engine with EGR, okay, exhaust gas recirculation. I have also made a separate video on ways and methods in detail. It's a lengthy video of maybe more than half an hour. on how to reduce NOx and SOx, all the methods of SCR and everything, all the selective catalytic reduction, all these techniques they have been discussed. We inject water in the combustion chamber, all these things have been discussed. Now we move to our topic, that is gas admission and gas injection. So when we speak about, so what is important here, GA is gas admission, as we have already discussed. Now when we see that combustion is based on a pre-mixed gas principle where pilot oil ignites an air fuel ratio. So here pilot fuel is igniting air fuel ratio, so we also have pilot fuel which is injected, and then on certain load after we change over from pilot fuel, that is maybe MDO, to gas injection. Okay, here we have when we speak about gas injection, use a non-premixed combustion process where fuel is injected and burned directly in the cylinder. So here it is non-premixed, okay, and fuel is injected and burned directly in the cylinder. Next, when we see, it's a low pressure gas fed, is gas admission. So just we are admitting the gas, it's not the injection actually altogether what is happening. Here you see it is high pressure gas is injected. Now when we see that low pressure engine with relatively high methane emissions and low thermal efficiency. So we have low pressure engine with relatively high methane emissions and low thermal efficiency. Here we have high pressure engine with low methane emissions and high thermal efficiency. Okay, now when we speak about, here gas is admitted to engine just after the piston has crossed the scavenge port in compression stroke. So gas is admitted to engine just after the piston has crossed the scavenge port in compression stroke. It allows gas fuel to mix well with the air in combustion chamber. Here if you see, gas is admitted to engine just before the piston reaches TDC. There it was before it can uncover the scavenge ports. Okay, just it has covered the scavenge ports. Just when it has crossed the scavenge port, gas is injected. Okay, here we have just it before the TDC and before the pilot fuel is injected. So before the pilot fuel gets injected, you have to have gas which has to be injected in, and both has to be in the compression stroke in both the cases. It allows gas fuel to mix well with the air in combustion chamber. So it is allowing the gas fuel to mix well. So here that may not be the case in the gas injection, because you have just before the TDC, so after some time the firing will take place, so you will not have proper mixing. Okay, now here we have high combustion gas temperature. So here we have high combustion gas temperature because relatively more fuel will be injected as compared to injection, because here you will have particles of fuel which is going. So here your combustion temperature will be higher in gas admission. So here it will be relatively lower combustion gas temperature. When we speak about this, so because of this now see gas temperature, because of this we will have high NOx emission. So NOx emission will be higher. Now because of this we will have increased greenhouse effect now, but tier 3 compliant. So now these are we will have here is increased greenhouse gas effect, and here what we have now offers high efficiency on both gas and fuel with significant reduction in carbon monoxide, nitrogen oxide and SOx emissions. Okay, low greenhouse effect but not tier 3 compliant without EGR. So now here it is wrong, it will be tier 3. Okay, so it is tier 3, though they are tier 3 compliant, sorry. So here it is increased greenhouse effect but tier 3 compliant. So these are the few advantages. Here you have better combustion because the mixing will be better, because from the scavenge ports only, after the scavenge ports only you have gas which is admitted. Here you will have relatively lower combustion gas temperature, so lower NOx emission, SOx emission, so all these things will be reduced, but they are not tier 3 compliant without EGR, that is exhaust gas recirculation. So when we speak about the gas admission engine, that is Combustion is based on pre-mixed gas principle where pilot oil ignites an air-fuel mixture, low pressure gas feed, low pressure engine with relatively high methane emissions and low thermal efficiency. Gas is admitted to engine just after the piston has crossed the scavenge ports in compression stroke. It allows gas fuel to mix well with the air in the combustion chamber. High combustion gas temperature, high NOx emission, increased greenhouse effect now but tier 3 compliant. When we speak about gas injection, it is used as a non pre-mixed combustion process where fuel is injected and burned directly in the cylinder. High pressure gas injected, high pressure engine with low methane emissions and high thermal efficiency. Gas is admitted to engine just before the piston reaches TDC and before the pilot fuel injection. Relatively lower combustion gas temperature. So they have relatively lower combustion gas temperature. Now they offer high efficiency on both gas and fuel with significant reduction in carbon monoxide, nitrogen oxide and sulfur oxide emissions, that is NOx and SOx. Low greenhouse effect but not tier 3 compliant with EGR. So these were the basic difference and surveyor expected points on the difference between MEGI and MEGA. So we will be covering in depth about MEGI, their constructional and how this gas injection is happening, because we have what is here today in the market is MEGI by MAN diesel and turbo. So XTF is by WinGD, they were previously known as Wärtsilä. So we'll be covering a separate video altogether about this MEGI engine. I hope it is clear for you. So I have tried to compile and bring it from different sources, different website, different materials available over the open platform. So please bear with it. Thank you so much. Thank you for your valuable time. All the very best.